Okay, so our period of the simple harmonic motion is given to us as 12.5 hours. So we're just going to use our equation for displacement in simple harmonic motion. And here we have omega. I like to use 2 pi times the frequency as omega. You could use 2 pi over t. So since t was given to us, 1 over t, which is the frequency then, here is 0.08 cycles per hour, because our time was in hours. So if I draw a graph of what that looks like, they told us from the highest point to the lowest point is d. So that means the amplitude of my displacement wave is d over 2. You can see that over here, also called x max. So I'm just going to go ahead and take my equation and plug in what I know. My amplitude is d over 2. My frequency is 0.08, so 2 pi times the frequency, and t is what I'm trying to find. X is my displacement. So what is t when x is 0.25 of d? So that's in between the max displacement and the midpoint of the oscillation. So right in there is 0.25 d. So I plug that in for my displacement, and the d's cancel out, and then I multiplied both sides by 2, and then since what I need to solve for is inside the parentheses with cosine, I take the inverse cosine, and so I get on the right side just what was inside the parentheses, and then the inverse cosine of 0.5 is pi over 3 radians, or 60 degrees, and now treating that pi over 3 as a number, I can solve for t, and I see that the time for the tide to go down by 1/4 the total change in tide is 2.08 hours. Now there is another way we could have done it. Here I've drawn the graph on Desmos, and I've done what I think is a very helpful tool. I've normalized my cosine curve. So I let the amplitude be 1, and the period is 1 as well. So if you make everything 1, that's called normalizing it, and then you just work with percentages. I'll show you what I mean. So here, this is the halfway point down, 0.5. This is the cosine curve. So I know this is 60 degrees, and my whole graph is 1. The whole period, or the wavelength, is 1, and I know that corresponds to 360 degrees. So 60 degrees over 360 degrees, that is 1/6 of a cycle. And I saw that the whole cycle took 12.5 hours. 1/6 of 12.5 is 2.08 hours.